SDI-12 networks provide our customers with the potential for some powerful sensor networking, but there are some risks inherent in that protocol. And the goal of this presentation is to give you an idea of some of the pros and cons and to help you decide whether or not SDI-12 is a good fit for your project, and if so, some things to think about for installation and maintenance of the project in the long term. Let's start out just by getting a feel for your experience with SDI-12. So let us know in the poll that should be popping up now if you've used SDI-12 in the past, whether you intend to use it on future projects, or if you're just learning more about data logging in general. Okay, thanks for your feedback on that. Let's move on. So we'll start with just what is SDI-12. We'll talk about that a little bit, and then we'll go into the pros and cons, and then we'll talk about actually designing your sensor network and what goes into that, and we'll wrap it up with some troubleshooting. SDI-12 stands for Serial Data Interface at 1200 baud. It is a standard protocol. Any SDI-12 compatible device should speak with any other SDI-12 device. You can get the details of the protocol at www.sdi12.org, and I do recommend visiting that site if you're going to use SDI-12 extensively in the future. It's a 3-wire interface, so the basic idea is networking sensors in a very simple, straightforward network. You can boil this down to the fact that it's a lot of smart sensors on a common data line. Decagon digital sensors have 2 modes of communication. There's a Decagon serial protocol, a serial string that is just given up whenever the sensor is powered up. And basically, you power the sensor, it spits out data, and then the sensor enters SDI-12 mode and stays in SDI-12 mode until the sensor is powered off. And to get the serial string, you need to power the sensor again, and then it will give it string and then go back into SDI-12. So here's kind of the scheme for just a Decagon serial string, where you have one sensor going to one logger port. The sensors aren't distinguished from each other, so you have to have a dedicated port for each sensor in the standard serial string. SDI-12, on the other hand, lets you put all 3 of those sensors onto one port. It's a 3-wire interface. You have a data line, the ground line, and the supply line. The SDI-12 protocol standard is 12 volts. Decagon sensors will accept any power between 3.6 and 15 volts. The key to this is that each sensor requires a unique address. It's a 2-way communication between the logger and the sensor, so that's one way that it differs from the DDI serial string, the Decagon serial string, in which the logger port is just listening for the sensor. In SDI-12, the logger queries each sensor by its address. The sensor wakes up and responds to whichever command the logger has sent it. Only one sensor is actually active at a time on a network. All the other sensors are quiescent and just listening for their turn to give data. One detail of Decagon sensors is that they will only work with the serial string for an address of 0. If you've changed the address to a non-zero address, all Decagon sensors will only work in SDI-12. I've got a brief list of Decagon SDI-12 sensors. The 5TEs, 5TMs, MPS2 are matrix potential sensors, and then the GS3 is the other soil moisture sensor, and then the ES2, VP3, DS2, and then our new sensor, the SRS, as well as our CTD and G3. One of the advantages of SDI-12 is that it's a cost-effective way to read data from many, many sensors. Decagon sensors can have 62 unique addresses, 0 to 9, lowercase a to z, and uppercase a to z. This does not mean that you should put 62 sensors on one port. There are a lot of practical considerations and environmental limits, but we'll get a little bit more into that later. SDI-12 also simplifies the programming. The commands in SDI-12 are all standard preset commands, so that it's generally just a few lines of code and you can get the response from the sensor. And they're cost effective because you don't have to invest so much in data loggers. One of the disadvantages of SDI-12 is that it can lead to serious problems one small problem can lead to large problems. If one sensor fails or is damaged, every sensor on that port can go down. This is one reason why we don't necessarily recommend putting 62 sensors on one port. If you have a short on one sensor, you will not get data for any of the 62 sensors. Now, a completely dead sensor will probably not hurt the network, but if some component or the circuit board in the sensor is shorted, then it can interfere with the communication of every sensor on that data line. I know you guys are thinking, this is great. I only need one data logger and I can run as many sensors as I need. I can put hundreds and hundreds of sensors out on just a few data loggers. We're all in a happy place. Come back from your happy place. Every sensor can be interfered with by one sensor on that has a short on the data line. I just want to drive this point home. It's one of the main disadvantages of SDI-12 and something that needs to be considered when setting up a network like this. So when you're networking, you need to start with an SDI-12 compatible logger. There are many different loggers out there with the SDI-12 protocol that can do this now. You also need SDI-12 compatible sensors. And then you need to address your sensors. For Decagon sensors, this is very easy to do with a ProCheck handheld reader, but you don't need a ProCheck. A terminal program or many loggers have a terminal emulator or terminal interface with their sensors. You can program your sensors with a unique address that way. And you also need to set up a bus or some way of getting all those wires together. So the bus is just a way of putting multiple sensor lines together. You can do homemade buses. A terminal strip can work as a bus. There are lots and lots of different options, and they're easily customizable. But poor bus construction can sink your entire network. So it's something that you definitely want to make sure is functioning well. So here's the idea. We've got 14 sensors here. We want to put them all into one port on the data logger. You just need some mechanism for putting all of those sensor wires together. For example, for a Decagon sensor with a red data line, a white power line, and a bare ground line, you need to have all those red lines going together, all of those white lines going together, and all of the bare lines going together, and then going into the appropriate logger port. This is just an example of a fairly simple bus that I constructed. There's nothing wrong with a homemade bus. We'll talk about a few guidelines for making a good one. This one, you can see it's just got 3 terminal blocks, and they're all soldered together with the white going to one terminal, the power line going to one terminal, the red data line going to another terminal block, and then the ground line is the third block. One thing to point out with this, notice on this, this is great for a bus that I use around Decagon for testing sensors. But note here where I've got that bare line just barely not crossing the red line. This is an example of a case that could cause a real problem. If you short those out, you won't get any data for any of the sensors on there. Okay, here's another example of a homemade bus. This is something whipped together by our techs in our R&D lab. It's not the best bus ever made. Troubleshooting anything in here is going to be problematic, but it does accomplish the function of combining all of your sensor wires into one so that you can run it to a data logger port. Here's another example of a homemade bus, and this is actually a pretty solid one and pretty reliable. We call it Medusa, but this is just several terminal blocks that have had jumper wires connecting the blocks. Or you can go with something nice like this, and if you're going to be using a long-term network with many sensors and troubleshooting is going to be key, then something like this might be more effective. We make this here at Decagon, and it's just a nicely constructed professional bus that can put 16 sensors, and you can actually link a few of these, and it has a few features like showing a red light in a bank of 4 if it detects a short. They're not available in large numbers, but if you are interested in something like this, contact us and let us know. But there are lots of different options rather than just having a central point for your bus. Something like this, if you've got sensors that are more dispersed, you can certainly do nested sensors and have nodes that bring different nests together into one data line. But beware that long cables can be problematic. Sensor networks with hundreds or thousands of meters of cabling can become a nightmare. For one thing, cables are expensive, and there is a limit to how much cable you can have on one common network. A good rule of thumb for this is about 1,000 meters of cable, maybe less with lots of long cables, probably more if you have lots of short cables. Also, this is an area that might not be the same for all different types of SDI-12 sensors. Decagon sensors have a lower impedance than most SDI-12 sensors, so you could probably get away with longer cables with our sensors than if you have sensors from a different manufacturer. Again, check with the manufacturer and www.sdi12.com if you have questions here. Okay, but you do get the potential to have very dispersed networks. And another thing that I would like to address briefly are the potential for lightning strikes. Basically, if you've got these large dispersed sensor networks, you could be building a giant lightning collector in the ground. A direct strike will fry everything, so you don't really need to worry about that. But even nearby lightning strikes can generate electromagnetic pulses that can cause a voltage gradient. And that gradient, that potential difference, is going to discharge through the path of least resistance, which is probably through your sensors. So if you get a case like this, where you have a lightning strike and you're getting a gradient from that strike through space, then the longer cables that you have, the more potential there is for problems to occur. So a case like this, it's your cable length is very long, so you're going to get a larger difference in that voltage gradient. And so it's a good idea to break up your networks in case if you are in areas that are susceptible to lots of lightning. In this case, breaking the network in two will be a lot safer for your sensors than having them all on one network. And again, shorter cables are going to equal a longer gradient, so you should run into a lot fewer problems. Troubleshooting. Well, let's talk about troubleshooting for a little bit. Probably the best thing that you can do for troubleshooting in an SDI-12 network is spread the risk out. Just because you can, say you have 40 networks, 40 sensors, just because you can put 40 sensors on one port doesn't necessarily mean that you have to. I recommend using as many ports as you have available. It's much easier to troubleshoot a problem it's much easier to troubleshoot 10 sensors on one port than it is to troubleshoot 40 or 60. A ProCheck made by Decagon devices is going to be indispensable for maintaining your sensor network. And constructing a good bus is also going to be the key here. So I always start with power when troubleshooting. If something needs power and doesn't have it, it's not going to work. But once you've established that you do have power to your network, start with, is the logger working? It's probably going to be the easiest thing to ascertain. If the logger is not functioning then properly, then your sensors aren't going to be doing anything either. And then the sensors are a good place to start, particularly if you have a ProCheck. And determining whether or not the sensors are doing what they're supposed to be doing is going to be key in isolating problems quickly. And then the third thing, if the logger is working fine and your sensors are working fine, is the bus working? Do you have a short there? Is there a loose connection somewhere? It's going to be your next step. I spoke about having an independent tester. The ProCheck is the best way to test Decagon sensors. It can help you address SDI-12 sensors, and it tests each sensor in SDI-12. So if they work on the ProCheck, the sensor is doing what it's supposed to be doing, and you can move on to another step in your troubleshooting. But the buses can fail too. This is an example of output from a bad bus in LoggerNet, in the Campbell Scientific software. Note, you just have a bunch of odd readings. You're getting data here and there, but for the most part, it's pretty clear that something isn't right. It's a good idea to do a continuity check if you have a homemade bus. The previous case that I showed you in LoggerNet, that was a bus that that was the first one that I ever made personally, and I was not, and still am not, an expert at soldering something. So there were several spaces that only had intermittent connectivity, and that turned out to just be a giant problem for my network in general. So most multimeters have what's called a continuity check, and you can just move down and make sure all of your ports have a good connection between each one. So the big question, is SDI-12 right for you and your project? Here's 3 questions that I think are integral to finding that out. Is it hard to access your data or your site? If you don't know whether or not there's going to be a problem, if you do know that there is a problem but you can't get to your site for several weeks, and how bad is it to not have data? If you must have every single data point, then SDI-12 may not be right, just because if one sensor goes out, you may lose data for all of them. And how hard will it be to find a problem? So there are some alternatives to SDI-12, particularly if you're out in the field. Multiplexing, it's still a very good way to put sensors in remote locations and protect your data and make sure that you have have the least risk to your system. Wireless sensors are great. Rather than running 1,000 meters of cable everywhere, it usually turns out to be cheaper and easier to maintain to have radio networks that transmit your data to a central location. And there are many options for cellular communication and networking through radios. Okay, it's quiz time. I've put together a brief poll, just 3 questions, and we'll see if we've helped you along a little bit here. Number 1, SDI-12 lets you put 62 sensors on one port and greatly reduces the investment in data loggers required for large sensor networks. True or false? Just give you a little bit of time here. And that is true. It's the main advantage of SDI-12 networks, is letting you put lots of sensors on one port. Next question. One shorted sensor on a bus of 62 sensors will bring down the entire bus. True or false? And that is also true, until the sensor that is causing the problem is removed. Once it's removed, all the rest of your sensors should come right back on. And the last question, a great SDI-12 application will be to put 62 sensors out in a remote location on one bus and not check on them for a year. And I think this is false. I would not recommend SDI-12 in this scenario. First of all, you don't know if there's a problem with your bus in a remote location, and it could lead to extreme data loss. And you're not checking on them very often. Even if you have a cell network in a remote location, if you're transmitting data to your desk and you do find there's a problem, it may be difficult to get to your sensors. In this case, a radio network or multiplexing maybe is probably going to be a better option. And so we have feel free to chat in some questions to us. I will take as many questions as I can here in the next few minutes. And if we don't get to all of your questions today, feel free to email us at support@decagon.com, or you can contact us at support if you have specific questions related to your network. And thank you for attending.